In this video, I discuss the explanation and some examples of product rule. Question is where the product rule is applicable. I always apply the product rule when we have two functions in multiplication, like shown here. If we have one polynomial function x square and second one exponential function e की power x, so these two functions are multiplying with each other, so we apply the product rule for derivatives here. Second one, you see some more examples in which product rule is applicable, like x cube sin x. Here again the two functions are multiplying, so product rule for derivative is applicable. Or we can apply the product rule on the function like e की power minus x cos x x3 plus 2 4x minus 9x square. There are plenty of examples like this where product rule is applicable. Let us just put a look toward this expression. In this expression, if we take one function as f of x and second function as g of x, so the product rule for derivative goes like this. Here we have two functions, one is known as f and second one is known as g. Now the derivative of f of x into g of x by the product rule for derivative is equal to derivative of first function into second function plus first function into derivative of second function. Basically, by understanding the concept, you take the derivative of f and then multiply it by g. This is not like derivative of both, like f prime and g prime. So here you are not taking derivative of g, just multiplying g with derivative of first function and add f as it is and multiply it by derivative of g. We can also write the product formula in prime notation as fg whole prime equal to f prime g plus g prime f. It doesn't matter, we can write it as in d by dx form or in prime notation. These both are actually same. In this example 1, we find the derivative of the function x cube sin x. Here notice that two functions, one is x cube and second one is sin x, are multiplying together, so we apply the product rule here. Let's write f of x equal to x cube and second function equal to g of x, which is equal to sin x here. So by applying the product rule on function f of x and g of x, the derivative of x cube sin x equal to derivative of first function f of x, which is equal to x cube. So we take the derivative of x cube, g multiply as it is, which is equal to sin x, plus first function x cube to derivative of second function d by dx of sin x. You all know the derivative of x cube is 3x square. By power rule, sin x remain as it is and the derivative of sin x is cosine x. We plug the derivative into the expression, so that's the answer. In the second example, we find the derivative of the expression e raised to power minus x cosine x. Here you notice these two functions are in product, so we apply the product rule here. Here we take f of x equal to e raised to power minus x exponential function and g of x equal to cos x trigonometric function. By applying the product rule on these two functions, the derivative of first function. So first function is e raised to power minus x, so the derivative of e raised to power minus x. The second function remain as it is, so cos of x remain as it is, plus first function. First function is e raised to power minus x and the derivative of second function. Here second function is cos of x, so we find the derivative of cos x. Now we plug the value of this derivative. What is the derivative of e raised to power minus x? By formula, e raised to power minus x remain as it is, and we take the derivative of power, which is minus x, and by power rule the derivative of minus x is minus 1, and we get the answer for the derivative of e raised to power minus x equal to minus e raised to power minus x. Cos x remain as it is plus e raised to power minus x, and the derivative of cosine x is minus sin x. That is the answer. Here in third example, we simplify the expression 5x square plus 4 into 7x minus 9. You notice that the two expressions are multiplying together. So we take f of x equal to 5x square plus 4, and the second expression in product 7x minus 9 equal to g of x. By applying the product rule on this expression, we first take the derivative of f of x. G of x remain as it is plus f of x into derivative of the expression g of x. By plugging the value of f of x and g of x into the formula, you will get d by dx of 5x square plus 4 into 7x minus 9 plus 5x square plus 4 d by dx of 7x minus 9. Now just plug the value of derivative into the expression. You all know by constant multiple rule the derivative of the term 5x square is 5 remain as it is, and the derivative of x square is 2x, and the derivative of constant term 4 is 0. Multiply it with 7x minus 9 plus 5x square plus 4 remain as it is, and the derivative of 7x is 7, and the derivative of constant term 9 is 0. It's your choice to leave answer like this or write it in simplified form. If you wanted to simplify, you can write this expression as by multiplying 5 with 2, you will get 10x into 7x minus 9 plus 35x square plus 28. Now just adding, subtracting and multiplying, you will get the final expression 105x square minus 90x plus 28. If you like this video, don't forget to hit the subscribe button. Thank you.